Okay, you guys, you should be writing these down. This is review. Did you guys do your homework this weekend?
Wait, what was it?
3-3.
Oh, I did. Can we go over it? I have so many questions.
Yeah, it should have been on Skyway. It should have been on Schoology. What you were supposed to do. We're doing 3-4 today and tomorrow, and Wednesday seniors don't come to school. Juniors have the PSAT. That's Wednesday. I don't know what the ninth graders are doing. Okay, what do we got here? You should be done. That's probably what to do tomorrow. No, we're doing 3-4 today. I know we're doing 3-4. But you guys are going to have work time because there's nothing to go over tomorrow. And you have a quiz tomorrow. Jack. Yes. Okay. What is the slope of C? 0. What's the slope of MX? M. Notice if you were gone, I don't think many of you were gone, but it's just the exponent times the coefficient. And then the exponent goes down by 1. That's all. So if we go down to x to the 5th, this would be 5x to the 4th. And this is nx to the n minus 1. And then what if you have some constant times x? It's just k. This is a pilot that we're doing. This is not our regular book. So we're piloting the book to see if we like it and compare it. Okay, what about h prime? You can do this one. It's g prime of x plus or minus f prime of x. That's nice. You can distribute derivatives over a sum or difference. But unfortunately, you can't do that with a product. Some of you may think you can. We're going to do an example where you see that it can't be true that it's just f prime times g prime. The biggest problem you're going to have is recognizing its multiplication of two functions. I really don't know why, but I know you have a problem with it, or everybody does historically. So, and the order doesn't matter because it's going to be multiplication. So it's g of x times the derivative of the second plus, then it's the second one times the derivative of the first. It would be nice if it were g prime times f prime. That would be wrong. I'm not going to prove it. I could try to work it out and prove it. But tomorrow's my last day to see you this week. Because Wednesday you take the PSAT. So that's it. We just have today and tomorrow for math. Isn't that amazing? And then you get to sleep on Thursday and Friday and Saturday and Sunday. Okay. That's the product rule. Remember what e to the x is? E to the x. Okay, now for the hard one. The quotient rule. And again, I wish it were g prime over f prime, but it's not. Okay, here's how I do it. I start in the denominator, I go up, and then I come back down. So it's f of x times the derivative of the numerator, g prime of x. Now, the multiplication rule, Jack, is plus. So the division rule is going to be minus. Okay, then I take the numerator, g of x, times the derivative of the denominator, f prime of x, all over the denominator squared. Oops, that's f of x. Just don't want to be able to read it, and I can't. Complicated. What do you guys think? Does it matter about the order in the top? Because of the subtraction, yes, it does matter. E to the x is e to the x. I will do that after I finish the quotient rule, and then I'll show you why the derivative of e to the x is e to the x. because that's just the rule. Proving it's hard. It's hard. I can try, but I don't know if you guys care. Okay, how can I remember the quotient rule? Well, it's high over low. So the derivative with respect to x, that's just an operator, like an adding sign is an operator. You see a plus sign, addition sign, you say, oh, I'm going to add those two numbers. When I see this d over dx, I'm going to see how the function changes as the x changes. It's a derivative. It's a rate of change. And I'm going to say that over and over again until we get it. But anyway, so how do you do that if it's a quotient? Well, it's low times the derivative of the numerator, low d high, minus, and then it's the numerator times the derivative of the denominator. High d low, over the square of low we go. So let's get it written down and I'll say it again. I just use, and I will all through class, it's the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the square of the denominator. And be really careful because sometimes we switch this up on h. We put f over g. So you got to read the problem. So if I do high and low, it's low d high minus high d low over the square of low we go. Whatever works. That's how you find the derivative if you have division of two functions. The d is derivative. Oh, we'll probably find more. Now, the question was, why is the derivative of e to the x e to the x? Well, let's go through and let's use our definition of a derivative. It's the limit as h goes to 0. We're going to do f of x plus h because I want it to be at any function, any value x, minus f of x all over h. That's just the slope of the tangent line. You should always be thinking slope. So for e to the x, it's going to be equal to the limit as h goes to 0, and it's e to the x plus h minus e to the x all over h. And then we have to remember, Brian, properties of exponents. Remember, x to the m times x to the n is what? X to the m plus n. Well, what if I want to go backwards? What if I want to go that direction? So if I have x to the m plus n, it's x to the m times x to the n. No. Only if it's this, x to the m to the n. Yeah. And in Calc 2, we do tons of stuff with exponents. So I'm going to rewrite this and pause. This is the limit as h goes to 0. This is e to the x times e to the h. If I go from e to the x times e to the h up, I can see e to the x plus h. I not necessarily, we see it going down. Do you see that these are the same now? Minus e to the x all over h. And then what could I do? Factor out what? E to the x, right? Well, I like doing this problem because there's something that's interesting that happens here. This limit refers only to h, not to e to the x. All over h. And you know what I can do with that then? I can pull e to the x out of the limit operator because that doesn't affect that. It only affects h. So this is e to the x times this limit. And I can't think of an easy way, because I haven't thought much about it, to prove that that's equal to 1. But you could graph it, and that will be equal to 1. So the derivative of e to the x is e to the x. Kind of interesting. Okay? So now we're going to turn the page and do one more. Okay, so you're going to turn your page. So we're going to do this, and I'm not quite sure why it's there. I don't know if it's in the homework or not, because it's really what I call the chain rule. So what's the derivative of e to the x? It's e to the x back again. So just trust me for now. I think we might need it in the homework. But times the derivative of kx is times k. But I can't imagine it's in the homework, so it has to do with the chain rule. And we haven't done the chain rule. If you look at the assignment sheet, we are going to have a test after 3.6. So we're splitting the chapter in half. That will be the last tests. Those will be the last tests of the quarter. So we close our grade book then. Lots of time left. Now, on Wednesday, right? On Wednesday, we multiplied problems 1 and 2 out. If I go back to those notes, I believe they're the same problems. But let's use the product rule. We can do it both ways. I do it the easiest way I can. So you don't have to use the product rule in this assignment unless you have to use it. Like down here, I don't want to multiply number 3 out. And the other thing is my goal here is that you can actually use the product rule. It's not so much the algebra. However, on the exam and the multiple choice part, they might test you on the algebra. But when it gets really complicated, like number 3 and even number 4 gets pretty complicated, you want to check your answers with the solutions online because you don't want to spend time doing the algebra. I don't want you spending time doing the algebra. I want you spending time doing the calculus. So this is the product rule. So it's the first one times the derivative of the second. So what's the derivative of the 2x minus 7? 2. Is that okay? The derivative of 7 is 0 because that's just the slope of a horizontal line. Then it's plus, then it's the second one times the derivative of the first, which is, what's the derivative of 3x plus 5? It's 3. Now, if I want to check my answer, and this isn't too hard to do, by the way, I should probably multiply it out and combine similar terms. So this is going to give me what? Jack, what am I going to get here? Well, I could get 2 for the price of 1. Any of them. How about that one? 6x plus what? See it over there? Plus, you should be doing it with me. Plus, how about the other Jack? What's this one going to give me? 6x minus 21. Combine similar terms, you get 12x minus 11. And then the last class wanted me to circle my answer. And the thing is, we don't want to circle our answers because if you end up doing a problem a couple different ways, there's 2 scenarios. You could do the problem 2 different ways. Then if you don't tell us which one you want, and we read both solutions, we grade both solutions, and we average those scores and round down. Yeah, it's pretty harsh. And we're told what we have to do. So it's not my decision. If you have a bunch of stuff written there, and it's maybe not even relative to the problem, and you have the right answer written down elsewhere, if you don't circle anything, we'll ignore the junk and go for the right answer. But if you circle the junk and you think that's the right answer, and your right answer is elsewhere, we'll ignore your right answer. So it's safer to not circle your answer, actually. I know it sounds crazy. If you're neat and organized, I don't think it's a big deal. If you're not so neat and organized, then it's a bigger deal. Because we search through your work to find the right answer. If you circle the wrong thing, then you won't get the points. Now, if I multiplied this out, because we did this, I'm pretty sure we did this problem. What is this multiplied out? It's 6x squared plus, oh yeah, that was 10x minus 21. It was minus 11x, right? Minus 35. What's the derivative of this? 12x minus 11. Well, it's up to you what you think is easier. They're both, I got to get the same answer no matter how I do it. If you thought that the product rule was silly, we don't have to do all that work, then that means I would take the derivative of 3x plus 5, which would be 3, times the derivative of 2x minus 7, which would be 2. And 3 times 2 is 6. Nowhere is that in this answer. So it has to be wrong. So I'm proving it to you by counter example, more or less. Do you want to square that out? We're going to try the product rule just the way I practiced. But we did square that out last week. It means this, minus 5x plus 8 times minus 5x plus 8. Okay, so it's the first one, minus 5x plus 8 times the derivative of the second one, negative 5. And some of you are clever and say, hey, wait a minute, I got two of those, don't I? But we'll just do it blindly. Then it's the second one, minus 5x plus 8 times the derivative of the first, which is negative 5. And again, some of you will say, oh, I got two of those. But we'll just do it. So let's see, this is 25x minus 40 plus 25x minus 40. And sure enough, I do have two of those. So it's 50x minus 80. You can check your work from last week. And I don't want to multiply out number 3 for sure. I can. You guys don't like that. So why don't we just use the product rule? You ready? Okay, you should be ahead of me. So it's x to the 8th minus ex plus 3x squared. So it's the first one times the derivative of the second, which is what? Negative 12x cubed. Plus, leave myself some space over there, negative 3x to the 4th plus 2. It's all in one line, but I don't have space. Times, what's the derivative of x to the 8th? 8x to the 7th. Derivative of minus ex, minus e, plus 6x. And again, it looks kind of complicated to multiply out, so I'm not going to. You go online, you check your solutions, and you imagine them up and say, oh, yeah, that's exactly what Mrs. Erzman got. Hopefully. Just leave it, yeah. That's going to be one of the hardest things for you to do is to not simplify. That's it. Unless you want to multiply the trinomial times the binomial, which I think I might as well have done that to begin with. Would have been easier. Okay, you ready for the hard one? Noah. Because if it's free response, you never have to simplify. Now, next question, you guys. How do I know I can stop? If it's free response, you never have to simplify. If it's multiple choice, you're going to have to match it up. And come next spring, we will do the problem where it was really difficult to do algebraically to get it to match. But yeah, that's one problem. And I would hope they wouldn't put something on there that hard again, because that was pretty hard. Generally speaking, we just leave them. If they're easy, like the ones above, they were pretty easy. And if they asked you to find the value of this one, x is 2 or something like that, you would just put the 2 in these places for x, and you would leave it. Do not find the actual value. Just leave it. But you have to put the 2 in if that's the case. Okay, what about this one? Now, this is the quotient rule. So it's the denominator, negative 3x to the 4th plus 2 times the derivative of the numerator. What's the derivative of the numerator? Minus 1. Oh, we did that already, right? Then it's what? Minus, remember it's minus here. Then it's the numerator, x to the 8th minus x plus 3x squared times the derivative of the denominator. We got it over there, negative 12x cubed. Don't forget the denominator on this. It's all over the denominator squared. Never multiply that out. They're never going to ask you for that. You just leave. I would just leave that. But you can't check your answers in the back of the book if it's like this. You're going to have to go to the solution set. One more, and then we have questions. Yeah. Yes. You do not have to simplify. If you had just left it, yes, on the free response. But this would actually, number 1 would probably be in the multiple choice, which case then you'd have to match it. But they have had some hard ones algebraically. Not quite like that, because that's not the point. The point is to measure your knowledge of calculus with a little bit of algebra. Now, I think it's easiest to do this problem by dividing, but we're going to use the quotient rule. Okay, you ready? Remember, it's the denominator times the derivative of the numerator. So what's the derivative of the numerator? Sophie? Good. I think somebody did their homework. Yeah. Yeah. I know, it's good. Minus, then it's the numerator. And it's just a matter of memorizing this. Well, how do you memorize it? You do the homework and you practice it. Because that's how come you think I know it? Because that's why. This is my second time today. I better do it right, right? 2x all over. And if you don't know how to square x squared, then leave it x squared squared. As long as you do it right. Which is x to the fourth. Pardon, Haley? Yep. You could. Now, if this were multiple choice, this is reasonable to have you simplify. And the reason being is they're going to look for, are you going to distribute that negative sign? Because it's often missed in the multiple choice. Yeah, but this is a little more complicated than what they'd have. And you have access to all the AP questions. You have all the multiple choice that we have, at least, and you have all the free response questions. They're up on Schoology with the answers, with the solutions. So you could go and practice. If you're curious, you can go and look at them. And that's all there was to this section. So the question now is, the questions you have out of 3-3. That's good. We had 25 minutes. Now, if you haven't done the homework, as we do questions, you should do the homework with us. I will post on Schoology what's on the quiz, because I got to look at the quiz. Well, you know how the book, it tends to make things a little harder. But, yeah, for the most part. Oh, okay.
I don't get like numbers.
51? 50?
Like the G prime and then G prime.
Wait, which one are we looking at?
No, here,
We're going to look at homework.
okay, ready? I have a question. I wrote it down.
Cute.
18.
Now, let's start closer to the beginning. Yeah, 18 is.
It's recording.
Yes. Did we do 18?
Oh, I did that.
Was that a sign? 18?
Yeah. 18 and 24, page 151, right?
Yep. Now, are you getting used to the fact that these are dummy variables? They could be x's. I don't care.
And then we have to do 37.
Every what? Okay, you guys, all we know is the power rule. Right, Jack? Molly? All we know is the power rule. So I have to change square root to a power. And, you know, if you don't like the 1/4 there, let's make it this way. Do you agree that that's the same? This is equal to 1/4 times the square root of s. Okay. So let's take the derivative. Okay, Riley? I'm going to do 1/4. Now, we didn't have the product rule before this, so you had to ignore the 1/4. But let's actually show you why I can ignore the 1/4. What's the derivative of s to the 1/2? It's 1/2 s to the what? Negative 1/2. Then it would be, using the product rule, plus, then it would be s to the 1/2 times the derivative of 1/4, which is 0. Oops, I don't want that color. What's the derivative of 1/4? This means find the derivative. What's the slope of 1/4? It's 0. It's a constant. Derivative of any constant is 0. So that's why I can ignore the 1/4 and just do this derivative. So that's it. So the answer is 1/8 s to the negative 1/2. But you know, I don't like negative exponents. So I'm going to put it in the denominator. And it's 1/8 s to the 1/2. I don't like fractional exponents either. 1/8 square root of s. That's it. Oh, you could have stopped right here. It's perfectly okay. However, if it's on the multiple choice, this might be the answer. So you have to be able to do that. Yes. 1/4. Yeah. I just use the power rule. So you pull the 1/2 in front and then subtract 1. Yeah, just a minute. Did you see that? Yeah, that's the power rule. The derivative of x to the n, where n is any number, is n x to the n minus 1. N is any real number. It could even be a radical. Okay, you guys? What if I have x to the pi? Okay, shh, guys. What's the derivative of x to the pi? Well, it's pi times x to the pi minus 1. It doesn't matter. Good. Okay. Yeah, it doesn't matter. It's 3.1415 minus 1, so it's 2.1415 minus, but whatever it is. Yeah. Jack. If you have this, now if you have like, if I want to find the derivative with respect to x of 1 over, sorry, the square root of x, like that, I have to do a couple things. Because all I know is the power rule, and that is a power. So first, it's this. It's d dx. I don't want to use the quotient rule. I don't have to. 1 over x to the 1/2, right? Isn't that what square root is? Which is the derivative with respect to x of x to the what? Negative 1/2. So what would that derivative be? Negative 1/2 x to the, go down 1, negative 3/2. Easy to go the wrong way. Yes. And if you did the homework, it should have been fairly easy for a while at least. 37, find an equation of the tangent line at A, and then they want you to graph the curve and the tangent line. Well, you could cheat a little bit, but okay. Well, you could draw the tangent line. There's a function on your calculator that does that. So 37, right? Is it 37? Or 36? 37. Okay, y equals e to the x, and my point on my curve is the log of 3. Is this still 3.3? We're doing questions on homework. 3.3. I can go back to 3.2, though. I don't care. And I want the equation of the tangent line. Well, if the x-coordinate is the log of 3, what's the y-coordinate? It's e to the log of 3. Now, we haven't reviewed logs. But does anybody remember what e to the log of 3 is? It's just 3. Exponentials and logs undo each other. So this is log of 3, comma 3. So the equation of any line is y minus y1 equals the slope x minus x1. So they asked me to write the equation of the line. So I start with that, and I say, well, I need to know the x-coordinate, which I have. I need to know the y-coordinate, which I have, and I need to know the slope. And the answers are going to look weird because these are exponentials, but that shouldn't be that big a deal. Okay, so it's y minus, what's the y-coordinate? 3 equals my slope. I'll figure that one out. I always save the worst for last. And then it's x minus the log of 3. Okay? Riley, question on this? How do I find the slope now? M is equal to the derivative with respect to x of e to the x. Well, that's the easy one. What's the derivative of e to the x? E to the x. And we will evaluate this when x equals, what's x? Log of 3. So what's e to the log of 3? Now, you could leave your answer e to the log of 3. Nothing wrong with that, unless it's multiple choice. Which I could actually, your y is right here. This is f of e to the log of 3. F of 3, sorry, I said that wrong. There's your y value. So the slope is, I know it looks weird, but that's what it is. 3, and it's x minus the log of 3. Do you have any problems graphing these things? Do you want me to graph it? You don't want to take the time. Okay, it's fine. ln, natural log. Everything's going to be pretty much natural log. You hope it's not log because it's way harder. You want natural. Well, I could just graph it by hand. So y equals e to the x, looks like this. And when x is equal to the log of 3, okay, let's see, the log of 1 is 0. So the log of 3 is going to be, did I say that right? Yeah, it's small. It's going to be here. Yeah, it's a calculator problem. But that's what it would look like. Slope looks like it's about 3. 1, 3. As good as I can draw. Okay, more. More. 47. How come nobody else has questions? You can't do 47. Oh, yes, you can. 47. Well, now, you guys, we have the quotient rule. But this is what's kind of nice about this problem. Do I need the quotient rule? I can divide that. I'm not going to do polynomial division. How about if we factor it? Can I factor that? It's x minus 8, x plus 1, over x plus 1. So as long as I'm not at negative 1, my function looks like that line, x minus 8. Doesn't it? That's what it looks like. When I first look at that, I go, I don't know what that looks like. But yeah, I do. And what's the slope of that? What's f prime of x then? No, the slope of this is, slope of x is 1, and the slope of 8 is 0. I could do long division. I could use the quotient rule and simplify it, and everything better go away except for a 1. Do you want to do it?
Do it. Yeah.
I'm just, if you don't, no, because it wasn't part of the assignment. Always, once I've introduced it. But what I have thought, now that I know the quotient rule, would I think to factor that? No. That's why I originally said, oh, you can't do that. And I go, why would they do that? Okay, it's the denominator times the derivative of the numerator. What's the derivative of x squared minus 7x minus 8? 2x minus 7 minus the numerator, x squared minus 7x minus 8 times 1 over x plus 1 squared. Now, I have more algebra expertise. I would factor this into x plus 1, x minus 8, and factor out the x plus 1. But you wouldn't think to do that. That's the trick that they're going to do on the exam. So let's see. It's going to be 2x squared plus 2x minus 7x minus 5x minus 7. Now, here's the other trick. If you're going to do this, it's going to be minus x squared. What's plus 7x plus 8? Is it so easy to make those sign mistakes? Okay. And then it's x plus 1 squared. Okay, so if I simplify that, the first way was a lot easier. It's x squared plus 2x plus 1. What's true about these two things? What's true with that trinomial? They're the same, aren't they? What's x plus 1 squared? It's easier than factoring. It's x squared plus 2x plus 1. The quotient rule made it harder. Hey, I think it's cool. What about math tells you what to do? 39. Oh, 39 is an excellent question. What did I just do? It's pretty much skills, yeah. I'll put it up on Schoology. Oh, I didn't do anything. Those guys did. I forgot. Well, they could do this problem. It says, for A, find the values of x for which the slope is 0. F of x. This is part A. Well, what's the slope? What's f prime of x? 2x minus 6. I'm not finding the slope when x is 0. I want to know the x values when the slope is 0. So 2x minus 6 is equal to 0. This is where you would get your point on the exam. I know you could probably just give me the answer, but that's called a bald answer, and you won't get anything for it. They want you to make the statement, and then now you can tell me, yes, some of the algebra is as easy as this. X equals what? 3, because I don't care how you solve that. Guess and check is perfectly okay. The slope is equal to 3. So on part B, they say find the values of x for which the slope of the curve is 2. So B, I want f prime of x equal to 2. Not x is not 2, but I want to find out what x is so that the slope is 2. So 2x minus 6 equals 2. You could do trial and error. And so 2x is equal to 8, and x equals 4. And by trial and error, you would put in numbers here and try them until you got the right answer. Hopefully it's not something nasty. If it's without the calculator, the numbers will be relatively easy. I saw somebody take 15 to the 6th power on the exam by hand. It was without the calculator. Yeah, I know, that was crazy. He wasted a lot of time, he or she. So if you're in the non-calculator part of the exam and you think you have to do a hard calculation, remember, you're not going to be doing a hard calculation. You just leave it 15 to the 6th. Oh, okay. There's another one I want to do, and I want to do 64. Is there anything before that? The reason why I want to do 64, it's one of those you have to know. And Mrs. Hirschman maybe just didn't see it. So this should go into the important place in our notebooks. I thought. This is a limit. Okay. Jack, where's your homework? Yeah, this is free. During class? Oh, good question. Is that 0 or is that infinity? Okay, you guys? What happens if n's getting really large? What happens to 1 divided by n? It gets really small. And so this is getting closer to 1, and that's getting big. So some of you think the answer is going to be 1. Some of you think the answer is infinity because you're thinking, you know what? That's not 1. Is it? Well, we could put some values in and we could try it. In fact, let's start there, finding that limit. N. Okay, so I'm going to click N. Those are N's. As N approaches infinity, yeah. N. Okay, so what I'm going to do is take a 1 here. Now, that's pretty close to 1, isn't it? And we're going to make that, well, I got to really be careful about that.
1 billionth power. Do it. Do that.
Okay, we'll do it that way. That's 10 to the what?
Billion.
10 to the 9. Okay, still, but is it getting closer to 1 or is it getting further from 1?
Further right.
It's getting further. So let's take this 1.001, and now let's make it 10 to the, what do you want to try? Hundredths? That's pretty big, isn't it? Well, we'll find out. Is that infinity? That's 2.7.
That's infinity, all right.
Anybody recognize? That's not infinity. Well, let's graph it. I already have it on my calculator. So 1 over x to the x. This is tug of war. 1 is pulling, infinity's pulling. Who wins? Now, if I graph it, zoom 4.
Infinity is any number of small best.
No, infinity is a concept, and it's getting bigger and bigger. It looks like there's a limiting value, doesn't it? So if I go through my table set, second table set, whoops, where is it? Second table set. I start at 0, and I made that 10. Well, let's want to do 10 to the 12th. That's pretty darn big, right? Enter. And now we're going to go into our table, second table. Obviously, it's 0. I have an error, but over here, anybody recognize that number? That's E. There's a limiting value. It's not getting bigger and bigger. This is E. Now, in your notes, you need to know that that's E. So I write it down. Because when you see it, there's other forms that we can have of that. That one will come back and haunt us. And you've seen it before. It's called PERT. Remember PERT? Do you remember the formula for compounding? Well, I'll use P. Because that's PERT. P equals P naught. And it was 1 plus R over N to the NT. Do you remember that? That was compounding, like quarterly. N was 4 times a year. And there's your interest rate. I would have to do a lot of work, but I could get it to manipulate to look like that. And they said if you compound continuously, remember PERT? You don't remember PERT? Right there, for you did interest. Okay, if you didn't, we're going to have to do that, okay, because that's important. To manipulate this, to get this, I can. But I don't want to take it, unless you want me to. I can right now, but I can manipulate it. Or I can challenge you to say, how can you get this limit here to look like that? This is not, it's pretty close to 1. It's a tug of war. They're battling. I can prove it to you, but not today. I actually can prove it to you, but not today. Okay, we still have 5 minutes.
Ms. Holmbetsky, is tomorrow going to be a hard day?
Tomorrow is the quiz and work time. So the quiz will not take you the whole time. Did you have to do 52 through 55? 52 through 55 are very typical AP questions. Where are the quick checks? Oh. Do the quick checks. The answers are in the end of the section. Yes. 40 what? 41. This is 3.4 day 1. I don't know. I don't go that way. Oh, now 41 is another good problem. Okay, you guys? Shh. We have to start getting you some AP problems. Find the slope. Hey guys, we won't get this done, but we might be able to. Okay, 41A. You guys, when that's not time to close up, find all the values of x for which the slope of the curve, 41. Find all points on the graph at which the tangent line is horizontal. What does that mean? Tangent line is horizontal. So it looks like this, right? The slope is 0. So you want f prime of x equal to 0. So what is f prime of x? 8x squared minus 6x minus 6x. Oh, I did 2 cubed. Thank you. Okay. Now I want where this is 0, I am going to factor out a 6 to make my life easier. Is that easier to factor? Oh, it's way easier. X minus 2. Now, if it doesn't factor, you know it's going to be quadratic formula. So x is equal to 2 or negative 1. The tangent lines will be horizontal. And you knew this was a cubic, right? And you remember what cubics look like? They look like this. So you're looking for this point and that point. It's always useful to visualize. Is that okay? Plus 4. But that's derivative is 0. You know what's interesting? Out of this class, no matter what you do in your life, when you get to be my age, somebody's going to ask you what the derivative of x cubed is, and you're still going to be able to tell them.
No.
Yeah, even when you're ancient like me. It's true. Ask your parents if they ever took calculus, if they know what that is. They'll say yes. Hey, what are you guys doing here? Okay, we'll do it this way.